what we're going to do is, this is a fast and furious tech panel. Today, you've seen so many different ways that IoT can be deployed, but these things don't happen just for sheer, luck. There's a lot of stuff that goes behind the scenes. So we're going to get a little bit unpacked about what happens behind the scenes. And we're going to look at the through to the right choice of sensors, all of the great things that Derek was saying about trying to pull together all these moving parts, moving then into the applications and the use cases, and then finally closing up with some really great examples of how data is being used and shared. So I'm going to introduce Sam Fisher from ICT International. We have represented Tasmania today, Chris, because Sam is calling in from Hobart. So
thanks.
Oh, no. Oops. There we go. Thank you, Sam.
Thanks, Catherine. Hi, everyone. I'm Sam Fisher from ICT International. We're a business that's been deploying and developing environmental monitoring solutions for over 40 years now. We're headquartered in Armidale, New South Wales, but as Catherine said, I'm out of Hobart. And we really specialise in plant, soil and environmental science. And I think Catherine really nailed it in the introduction this morning when she was talking about the evolution of telemetry, because coming from a hydrometric field, which is my background, that's what we've really seen. We've been collecting field data for over 50 years as an industry, but the rapid shift over the last decade and the miniaturization and the move to an open standard has really progressed the industry and changed the way we're doing things. But what we see is a lot of the problems are fundamentally the same when you're collecting field data, in that the constraints and the risks remain unchanged. So where you've moved from a station that's a shed on a river to a shed in a monitoring solution in a box, a lot of the problems you've historically seen in deploying these monitoring systems remain unchanged. And a couple of the constraints are obviously deploying your data or your sensing in a manner that's going to yield you a representative data set, provide some capacity to ongoing maintenance, which I think gets overlooked time and time again, and that is sensor cleaning and calibration requirements. So when you're planning and you're looking at a sensor, that's one thing we definitely recommend you look at. And then if you do have to maintain it, how that fits in with your OH&S, and whether you're climbing up poles to clean a sensor or fix some bearings on an anemometer, whether you can fulfill that in your OH&S program. And then your risks, and in hydrometrics, you're deploying electronics into an environment that floods and that is often prone to vandalism in the urban environment. So we sort of look at those constraints and risks when we're planning to deploy a system, and come up with try and come up with a system that's going to tick all those boxes. And this is a quick example of an installation we did for Redland City Council earlier this year to do some in-stream water quality monitoring. And as you can see in these photos, all electronics is accessible at ground level. So the person going out to maintain the system can drop a pole to physically wipe down a solar panel, check your electronics inside your box. The sensors, which aren't cheap, housed in a steel cased lockable enclosure, and they can be sleeved and pulled out from bank level to do your cleaning, which with any water quality sensor you're going to have to clean it, and to do a calibration, which is for these particular sample of sensors, generally 6 to 12 months. constraints. So that's something that you need to consider at the outset and plan your installation and your monitoring program around those constraints and risks. Thank you.
Closely with us on a number of environmental projects, and the complexity is definitely shown in that slide. So now I would love to introduce Phil Locke. Phil has been a great partner for Mesh from the very early days from the ARCS group.
The bandwidth's maybe a little bit limited. Can everyone hear me okay?
So, yep, just get to this.
Yep. So Phil Locke is my name. I am a co-founder and director of the ARCS group. We have been in the rail industry historically for around 35 years, and in the last 7 years been engaged in the smart city technology area. Our background in rail has been SCADA, so we've taken those engineering principles and brought them into the smart city and IoT world. I want to talk very quickly about the Moreton Bay rail link pathway that James Pete mentioned earlier. We were given a task to create an adaptive lighting solution for that pathway. We had an existing LoRaWAN light controller, however, it didn't fit the purpose, so we developed and extended our current range to include a LoRa-based NEMA DALI 2 controller. The differentiator for this controller is it has a DALI 2 application controller on board. We believe it's the only one in Australia, if not the Southern Hemisphere. It allows a NEMA fitting to be on top of the light, and then a Zaga presence detector on the bottom of the light, which creates a tactical light control locally. And that data and information is then brought up to our middleware platform called MeshNet Vision, which we've created from scratch to assist us in our engineering and data analysis, but also normalize the data up to the higher enterprise system. So it's a fully functional user interface. I've got a little bit of a demonstration there of how these lights work. We've employed one of our young engineers, and you'll see him walk underneath these lights in our office in Western Australia, and they come on tactically. These lights you're seeing there are actually about to be deployed with Michael and his team related to the turtles in the Sunshine Coast. But you'll see the light come on automatically, and James, I think, demonstrated a screen where you can control the amount of time that light is on and when it goes off, and then the normal level of light control. So we developed these from scratch. We build and design them in our Perth engineering office, and we believe we're one of the very few Australian-owned and designed IoT companies in this space. We're known as problem solvers, and we'd love to have a problem to solve. Any questions, go to our website or give me an email or a call. I think that's a quick way to deal with it. Thank you, people.
Thanks, Phil. That was great. And the technology worked, which is even better.
Yeah.
So you've seen the planning and design, the choice of the sensor, the whole, things to think about for installation. Yeah. And of course, the shared local technology being deployed in the lighting area. Now I'd like to introduce Paul Painter. Paul is from Peclet Technology, and Paul and Mesh kind of follow each other, but he'll explain a little bit more about data. So I'll just carefully put the slide on. There's a little bit of delay. There we go.
Cool. Thanks, Catherine. Hi, everyone. As mentioned, my name is Paul Painter from Peclet Technology. My company specialises in data analysis and visualization. We use a multi-purpose SaaS platform for smart cities, IoT, and open data. It's called Open Datasoft. And on the screen, you'll see 3 examples using the Open Datasoft platform. On the left is the City of Greater Geelong have a Weather Together program, which is working with their community to improve the accuracy of weather data. Residents can volunteer to host the council's LoRaWAN weather sensors at their home or workplace to record temperature and humidity in different parts of the city where climate can vary significantly. and that data can be visualized on the public-facing dashboard. In the middle, Randwick City Council is using multiple data sources to be visualized on digital beach displays to help improve the beachgoers' experience and safety in Coogee Beach in New South Wales. And on the bottom right, just recently, Open Data Soft has been integrated with the New South Wales and Victorian Digital Twin, and I think Queensland shortly as well. So, and that's real-time IoT data can be sent to those digital twins, which I can show a demo later if anyone's interested. Now, I'll quickly share my screen. And Catherine, yell out if you can see that screen.
Yes.
Yep, you can see the weather together screen. Fantastic. So this is the live weather together dashboard that anyone can go to right now, where the residents are going to be installing in sensor in the backyard. They're going to provide an image of the location of where their sensors are, where they can also view on a map. There's currently 3 sensors that are installed, but this is going to grow to about 50 sensors. They can come in and see the local weather data or the historical weather information with some sort of basic filtering capabilities. Then they can access it or download the data, but then you can go into view the data on the Open Data portal, Open Data Soft portal, where you can do really more analysis on that data. You can obviously see the table. You can come in and visualize and create your own maps. You can come in and really analyze the data like Power BI. It's, you know, Power BI for everyone internally and externally. You can actually share this via URL. You can embed into websites. You can edit in advanced mode. You can come in and export the data in multiple formats. You can, you know, do self-service API to send data off into different applications, or you can share via social media. Now, with the Randwick Beach display, you can see here multiple data sources coming from Environment New South Wales for safety, information and pollution, lifeguard reports, and multiple sensors from, you know, the meshed LoRaWAN, whether it's lockers, barbecue, waste, parking, ride share, etc. And for more use cases, yeah, please feel free. We have an open data portal called data.peclet.com.au where we upload all our clients' use cases in open data portals. Thank you.
Thank you, Paul. So a couple